Well, folks, this is Guruji Online, and I am Sanjay Singh speaking from this platform. So, today we are going to solve some problems pertaining to kinetic theory of gases. These problems I have given in the mock test paper dated 17 February 2020. So, this is the first problem, and it says air at initial volume 0.15 meter cube and at gauge pressure 104 kilopascal is expanded isothermally to a pressure of 102 kilopascal and then cooled at constant pressure until it reaches its initial volume. So we have to find out the work done by the air. So here what we are given, it is a isothermal process, and for isothermal process we know that delta T is equal to 0 and delta internal energy is also 0, but Q is not 0. Here, what are the parameters given? That is VI, that is initial volume, 0.15 meter cube, and PI, that is initial pressure, that is given as 104 kilopascal, but this is basically gauge pressure. So we have to convert it into proper pressure, that is 101 kPa, means initial pressure is basically your this 205 kPa. Now this air with these initial parameters is expanded isothermally to a pressure of 102 kPa. That means your pressure is now 102 kPa. We don't know this. It is the initial process up to this. So here we know what is the work done is basically P dV, or we can write it as N R T dV upon V, that is VI VF, because PV is equal to nRT for ideal gas. So this will be nothing but nRT here V log VF divided by VI. We know PI VI is equal to PF and VF. So from this, VF upon VI is nothing but your PI upon PF. This we can simplify, and RT we can again write it as PI VI ln PI upon PF. Here PI we know 205 kPa. VI we know that is 0.15 meter cube into ln 205 upon PF is your 102. So this will give you 21,465 joule. This is the work done in our initial process. Now, the second process, it says the same gas is cooled at constant pressure until it reaches its initial volume. So, in this process, how much will be the work done? That will be W P, it is the constant pressure. P, we can write P or this PF, because this pressure will be maintained throughout the cooling process. We can write it as PF and then VF minus VI. Here again PF this will be your final pressure, will become the initial pressure, initial volume, and this is the what volume? This is the volume. This volume we have to reach, and this is the volume of the gas. This will become VF, or we can write it as PF VI minus, then again with this process we can write it as VF is nothing but PI minus PF into VI. Correct? So this becomes VI PF minus PI. Here again VI we know 159. This is 102 minus 205 into 10 raised to 3. That is because this is in kilopascal. So this will give you minus 1540450 joule. So the net work done will be nothing but this minus this, and this will come as 6,015. So this is how we can solve this problem. This is the expansion. So positive work will be there. Now when it is cooling, volume will go down, negative work will be there, and this is the net amount of work done by the air. So we will go to the next problem, that is second problem. So this is the second problem of the mock test paper. It says a bubble of volume 15 cubic centimeter rises from the bottom of the lake with depth 35 meter. The temperature at the surface and bottom of the lake is 22 degrees centigrade and 4 degrees centigrade respectively. Naturally, find the volume of the bubble when it reaches surface. So in this problem, basically this is lake and one bubble is there, and this is the surface of the water, and this depth you are given as 35 meter. Here temperature is 22 degrees centigrade, here temperature is 4 degree, and this is the volume of the bubble, and its volume is given as 15 cc. So we have to find out when this reaches here, what will be the volume. This is initial volume. So in this case, we know our equation as PV is equal to N R T. Now suppose we take this A point and this is your A point. So N, naturally whatever volume of air it is enclosing, number of moles will be same. This is equal to PA VA upon TA, and this will be equal to PB VB upon R. Okay. What will be PA? PA is nothing but atmospheric pressure, that is, suppose it is P0, then it is P0 plus rho G D. VA we know, this is initial volume and this is R into TA. TA we know, that is 4 degrees centigrade. We can write it as, okay, we can let it remain as this thing. And here PP is nothing but this thing, VV R, R cancels out. Now VD, that is we have to find out VF at the surface will be nothing but P0 plus rho GD into your, this thing is there 15 cc upon TA is nothing but 4 degree centigrade, and this is your TB is nothing but 22 degree. We have to write this 273 plus 273 in Kelvin into P0. P0 is nothing but 101, that is atmospheric pressure. Rho we know, density of the water, G we know, D we know 35 meter. So if you solve this, it will come as 70. So this was a very simple problem. Now we will go to the next problem. This is the third problem, and let us first understand the problem. We have two containers and there is same gas in this container also and in this container also. Container A is at the temperature of 296 Kelvin and container B is at the temperature of 390 Kelvin. Volume of container A is, suppose it is V, then it is 4 times volume of the container B. Pressure inside this container is 0.4 MPa and pressure inside this is 0.1 MPa. Now, it says that suppose this, it is allowed to mix. Naturally, pressure will go from higher pressure, gas will go diffuse from higher pressure to lower pressure, and a point will come when the pressure of this and this will equalize and the flow will stop, and we have to find that final pressure. We are given one condition also, that temperature of both the container is maintained. Even after this equalization of pressure, this temperature is maintained. Okay, so now let us see how to find this final pressure. Basically, final pressure, that is PA dash will be equal to PB dash, and that we can write as PA. This is what we have to find out. So we know that suppose it has got number of moles initially, number of moles Na, and this is number of moles Nb. The total number of moles will be Na plus Nb. After opening of this N will not change. This will be like this. Number of moles may be distributed, but naturally this N original will not change in the final process. So we know N is equal to Na plus Nb, and we can write it as PA VA divided by R PA plus PB VB R T. Okay. VA is equal to V and VB is equal to 4V. When this clip is opened, it is allowed to mix, then what will be? Na dash plus Nb dash. This PA dash, and we also know PA dash is equal to PB dash, or we can write it as Na dash into RT divided by V. Now container's volume will not change, so we can write as VA and NB RT. This is basically, now temperature we are saying it is maintained. In this process also this will be TA only, and in this process also is will be TB only, and this will be VB. This can give you Na dash upon Nb dash is nothing but R cancels out, Ta Tb upon Ta and Vb upon Va. So this will be nothing but Va, Vb, if we write that, then this is 1 by 4 Ta Tb. Correct? If we put this value here, then N will be N dash Na dash plus n dash b. If we put n dash b, this will give you n dash b is equal to 4 ta upon tb into n dash a. So 4 n dash a, 4 ta upon tb. This will be n dash a 1 plus 4 ta upon tb. This must be equal to this equation, n dash 1 plus 4 ta upon tb must be equal to p. We can write va as v, and this is 4 v, then pa v upon r ta plus pb upon 4v upon r tb. Then what is this? Your n dash this is a. N dash we can write it as p dash a into v a upon r t a. R tb. Correct? This r cancels out. Va is nothing but v. This v also cancels out. Ta we know, Td we know. It is Ta is nothing but 296 Kelvin and Tb is nothing but 390 Kelvin, and Pa also we know 0.4 MPa and Pb we also know 0.1 MPa. So P dash A or P dash, that is final pressure, we can find out, and if you calculate this, this will come as this 1.74 into 10 raised to 5. So this is how, with this philosophy of number of moles will remain same if we add up the number of moles of the gases due to redistribution, we can solve this problem. So now we will go to the fourth problem. This is the fourth question. For the question, you can refer to the description part. I have given the full text of the question. Here, let us understand first what is the question. It says, this is the hydrogen beam. This is striking on a wall. and this beam is at an angle of 60 degree with the normal to the wall. Now, mass of the molecule is given as 3.4 into 10 raised to minus 24 gram, and it is striking with a velocity of 900 meter per second on an area that is 1.8 square meter. And we are given strike rate also. That means 10 raised to 23 molecules are striking per second. So total mass striking per second will be m into m0, that is 10 raised to 23 into this 3.4 into 10 raised to minus 27, basically kg. It is minus 20 is minus 24. You convert it into kg, that will be kg. This is the mass per second. Actually, it is striking at this wall due to this beam, and we have to find the pressure on the wall. Means due to this beam, how much pressure is there. So let us find out. You must have seen while studying the mechanics, this is the molecule is going like this on this wall. And when it will strike, it will come back like this. This is the momentum, and this is the, what will be the, this component, that is m v cos theta. Effectively, this component will be responsible for the developing the pressure, or you can say striking the wall, because it will have these two components, and this component will just go away. So let us concentrate on this. This is going like this and coming back. So what is the change in momentum? Is nothing but mv cos theta minus mv cos, that is 2mv cos theta. This is the your change in momentum, that is delta T. Now what is F? That is rate of change of momentum. Rate of change of momentum is nothing but 2mv cos theta upon delta T. What is pressure? Is nothing but F upon A. So this divided by will give you the pressure. So in this case, what will be the pressure? Our pressure will be 2 into, what is M here? M here basically this, because this much mass is striking per second. This is basically M upon delta T, and then V cos theta divided by A. We know this is A is your 1.8 square meter. This quantity is nothing but 10 into 3.4 into 10 raised to minus 27 kg, and we are given as 900 meter per second, and theta is nothing but 60 degree. Putting all these values, we can find out the pressure, and it will come as 1700. So this is the solution of this question number 4. Now we will go to the question number 5. So this is the 5th question of this mock test paper, and let us see what is the question first. We have 2 containers, and in one container the gas is there with pressure P and mass M1, and there we are given that the root mean square velocity of the molecules is, that is Vrms 1, and in this container it has got pressure 2P, means double of that, and mass of the gas is M2, and here the average velocity is basically 2.06 into whatever is RMS velocity here, quantity wise. So basically we have to find out M1 upon M2 ratio. What is M1 upon M2? So you might have seen while reading the chapter that Vrms is nothing but 3 RT upon M. Temperature is same of the both the containers. So in this case Vrms will become this. What will be Vrms 1? Why Vrms 1 will be nothing but this is, all other things are equal, and V average, we know that it is 8 RT upon pi M, and this is basically, in this case it will become, all other things are same. What is this M? It is the molar mass of the gas. Now we have been given this analogy, that means Vrms 1 V average, we can write it as V average is root 8RT upon M2 pi must be equal to 2.06 root 3RT upon M1. Correct? Now, when you will solve this, basically M1 upon M2 is what? It is nothing but M1 upon M2. With this, when you will solve this M1 upon M2 will come as 5. So this is the answer. So these were the solutions of this mock test paper pertaining to kinetic theory of gases. There are other questions also from 6 to 10 that I will give you in the next video. Please do subscribe this channel and if you have any suggestion regarding the videos or any other suggestion you would like to give, please do share your comments with the videos so that things can be made more beneficial for you people. So thanks for now. We will meet in the next video.